Hello learners, the topic is journey of a program. It means when the program is going to start, so where it travels, where it's going to end. Nothing but, so when the program is actually created, how it is saved, where it is saved, and how it is compiled, where it is compiled, and how it is executed, where it is executed. So let's see the complete journey of a program. Shall we go? Yes, let's go. The first one, so the program writing. So let's not worry about the writing of the program now. Why? Because we are at the beginning stage. So, but let us understand, we want to do the addition of two numbers here. Let's not see any sort of lines there. Let us not understand now at this point. But we can understand that's a program to add two numbers, add int A, int B, add two numbers simply. So that's why what we do is we'll save this program. Of course, we'll write the program first of all. We need to write the program, but how we'll write the program? So to write the program, we need to know the program features of any programming language. But now we are seeing the C language. So we have C, C++, Java, and Python, and a lot of many other languages, programming languages. But now we are going to see the C language. So in C language, of course, in any programming language, we need to know the program features. So what are the features we have? Then we need to understand the syntax and semantics of each and every feature. Okay, so for example, if for a given problem, then we need to apply some logic. And then as we have learned the features, we can write a program. So like that, this program was written. Okay, so that's a long journey, we'll see later. But as of now, yes, let's understand it was written. But how we write? Yes, so using a keyboard, or at times we may use a mouse, and of course we use a monitor also. So there's a few I/O peripherals are used. And then, so assuming that we have known the Java C programming features, and then we have written the program. So the program writing is done using I/O peripherals. As it is adding of two numbers, maybe I can give the file name of this C program as add.c. Any C program will have a file extension called .c. So now it is add.c. So let's have the file name as add.c. Okay. And when you save this as add.c, we need to save the program, of course. Okay. When you have created or when you have written the program, you need to save it. So you'll save the program as add.c. So when you save it, so it will automatically saved in the hard disk. You can see the hard disk here. So the add.c program is saved in the hard disk. It depends on the user, of course. It can be saved in a particular C directory or at some other folder of the user choice. Okay. So like that, the C add.c is saved in the hard disk. So that is program writing. So we have used I/O peripherals and the hard disk. And then when we want to compile the program now, so the program is created and the program is written and of course saved, and then we want to compile it. So when we want to actually compile the program, then the compilation command will be taken by the operating system called Windows. For example, so you may have your Mac, or you may have your Linux, or you may have your Ubuntu, any sort of Unix operating systems, or Mac operating system of Apple, or Windows operating system, any operating system. So operating system, what it will do is it will take the compilation command, and then, so for example, I want to compile the program now. So then what the OS will do is, so the program is already there in the hard disk. The program is there in the hard disk here. So that will be loaded into the RAM. The program which is add.c, which is there in the hard disk, it will be loaded into the RAM. So then, of course, the compilation process will be done in the RAM, and then add.b add.obj and add.exe files were created. Add.exe, of course, the compilation process, it will be done, means simply the English statements. See, you can just see the English statements, of course. Those are all the programming tokens and symbols and all. So those will be converted into a binary file, simply zeros and ones. So all the zeros and ones, now we can call it as add.obj or add.exe file, of course, binary file. Let's not go deeper there. So two files are created, which are from add.c, new files were created, which are add.exe and add.obj. So those were created, and then that will be saved in the hard disk again after the compilation. So that's the compilation process. Then when we want to execute the program now, so when we want to execute the program, now the add.exe will be loaded into the RAM now. The executable file of the actual program, that is in the form of zeros and ones, are loaded into the RAM now, into the RAM. Why? Because the processor knows only the language of zeros and ones. It can't understand any English statements. Okay, it can understand only two letters, which are 0 and 1. Okay, so then that's why when we give the execute command, the OS will again come into picture. It takes the execute command, and of course the add.exe file from the hard disk is loaded into the RAM, and then it instructs the processor to execute the program. So you can see the Intel processor here. Then the Intel processor, what it will do is, it will, of course, the address is also passed. Of course, it load the program into the RAM where it is loaded. So the address is also passed to the processor. Processor, please go to this address and execute the program. So that is instructed by the operating system. So please understand, operating system is the boss which controls all the operations, and processor or CPU is the noble and powerful servant which performs or executes all the operations. OS, operating system, is the teller which tells, which guides, which instructs, which controls everything, and the processor simply which performs, which executes, which does everything for us. All the operations will be done by the processor. All the operations will be controlled by the operating system. So that's why the processor will go to that address in the RAM and execute the program from the main function. See here, you can see the main function here. So in the form of zeros and ones, it is there in the RAM. So from that main function, the processor will execute the program line after line, and then gives the output of the program. So like this, if you can see that what we have done, so the program is created, it is saved in the hard disk, and it is compiled by loading into the RAM, and then it is executed again in the RAM by the processor, instructed by the operating system. So this is, the journey of a complete program, where the program is created and we got the output of the program. That is the end of the program. Hope you have understood. Thank you.